Hello everyone. Today we will discuss algorithm design in Unit 5 and we will discuss the merge sort and we will use the concept called divide and conquer. So in the name itself, while performing the sorting, we have to perform divide and conquer. You can merge. Divide first you have to perform the divide and then merge. Now let us consider a simple example. Later we will move to the program. Now we will consider integer type arrays 9, 3, 6, 5, 2, 8 and 7. So now let us consider these are the elements in our array. Now if I want to perform the merge sort, the first step what we have to do, we have to divide the array. How to divide that? Let us consider this is my first element and this is my last element. Indexing will start from 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6. So what is the array size? Array size is 7 and array elements are 9, comma 3, comma 6, comma 5, 2, 8, 7. This is before sorting and your first index is 9 and the last index value is 7. Now, as the name indicates, divide. So we have to divide the array into a small portions. Now, if you see, there are 7 elements are there. Now, what we are going to do, we have to divide the array into, we have to array into two pieces. So first, how we are going to make that? So now, first we have to find the midpoint of the array. What is the midpoint? Starting point plus, or we can say first plus last. First index plus last. You can write start or end. You can do. So first plus last by 2. So now first is index is 6, 0 and the last index is 6 by 2. So third index, your midpoint. So now what we are going to do here, we are going to divide at the third one. So here I am going to make a two pieces. I'm going to break this entire array into two pieces. So now in this, the total array divided into two portions. One is left array, which consists 9, 3, 6, and 5. And right side array, if you observe, here you have 2, 8, and 7. Now, first we have performed the divide operation. This we can say it's a divide. We divided. Right now. So once you divide a big array into small portions, now further you can divide this 9365. You can observe here. This is the first element. This is the first element, and this is the mid. And this index is mid plus one, and this one is the last index. This is the last one. 2877. 7 is the last element. Now we have to further we have to divide this into left portion and right portion. How to find this? Again, midpoint of these two. What is the midpoint? 9 3 will get separate here, 9 3, and here you will get 6 5, 6 5, and here you will get 2 8, and right side you will get 7. Further, is it you can divide into 9 in the left, 3 in the right. 6 in the left, 5 in the right. Again here, 2 in the left, 8 in the right. So now 7 is our, there is no other element to divide. So it is a base case. We can say it is a base. It's a final one. So as it is, you can write over here. So now once you got all the elements, first these 9 and 2, 9 and 3. As of now, we have performed the divide operation. This is divide. This is divide. All are divide. So we divided the entire array. Is it right? No. Now what we will do, we are going to perform the merge. That means we are going to perform 9 3. We are going to compare 9 3. Now I am going to create one array 9 3. So now once, for example, this is, let us take I, this is j. Now if you compare which one is smaller, that you have to index in the beginning. 9 3. 3 is less, 9 is greater. And similarly, 6 and 5, again, we can say it will come 5 6. Similarly, here you will get 2 8. And this one is 7. Now once you observe, what are the final arrays? We got 3 9 5 6 in the left side, 2 8 and 7 in the right side. Now again I will draw over here from the continuation. So now here we got one is 3, another one is 9 and 5 6. Here is 5 6 and 2 8 in the right side. This is 2 8 and 7. So in these two are in the right side and these two are in the left side. Now what we will do, again we are going to compare 3. Now what we will do, we are going to compare 3 with 5. So this is in the uh, I will this is in the left side and this is in the right side. Right now. Now first I'm going to compare. I will create one vector which is same as 1 2 3 4, and here it's a 3 elements. Now 3 I'm going to compare with 5. When I compare with 3 and 5, which is smaller? 3 is smaller. So now I will insert over here. Now I'm not bothered about 3. Now I will see the 9. 9 I will see. 9 if I compare with 5, which one is smaller? 5. So 5 I'm going to insert. So now 5 is done. Now 9 again we have to compare with 9. 9 I'm going to compare with 6. Which one is smaller? 6. And whatever the left, okay, 6 also we have inserted over here. 9 we are going to place. So now what we have done, we have performed the merging operation between these two arrays. Similarly, now first what we have to do, 2 and 7. 2 I have to compare with 7. So 2 is smaller. So 2 is smaller. I will write here. Now 8 and 7. If I compare with 8 and 7, which one is smaller? 7 I'm going to write. And finally, whatever the leftover element, I'm going to write here. Is it right? No. So these two are merging. Now, same operation, again we have to perform for these two. Again here, when I want to perform the demerge, again a big array I'm going to take, and here depends on how many elements, 1 2 3 4 5 6 7. So 1 2 3 4 5 6 7. Now first I will take 3. 3 I'm going to compare with 2. When I compare with the 2, 3 I'm compare with 2. Which one is smaller? 2 is smaller. So now 2 I'm going to strike here. I'm going to write. Now 3, I'm going to compare with 7. Which one is smaller? 3 is smaller. So now I'm going to strike 3 here. I will write here. Now what is the next element? So I'm incrementing. Let us take this is I and this is J. Right now, first I'm comparing with I with J. Whichever is smaller, I'm going to insert in the new vector. So this I'm taking as a new vector. Because of the new vector, your space complexity will become O of n. This is the space complexity, and time complexity will become O of n times log n. This is the time complexity. Okay, no. Now 3 compare with 7. 3 is smaller, so I strike out 3 and I have written. Next, what element is there? 5. So 5 I'm going to compare with 7. 5 is smaller. I will strike from here and I will write over here. Now, incrementing I. 6 compare with 7. Which one is smaller? 6 is smaller. I will strike here. I will write here. Increment the I. Here, this is my new position. 9 compare with 7. 7 is smaller. So 7 I'm going to insert. Again, 9 I'm going to compare with 8. So which one is smaller? 8 is smaller. I will write. So now all elements completed. Now 9 as it is I will write. So this is our finally sorted array in a ascending order. 2, 3, 5, 6, 7, 8, 9. Is it clear now? Same thing. Whatever the operations we have done. Now we have to write the code in terms of programming using Visual Studio. Right now. So first step what we have done. First, every step when we want to perform the divide operation, we have to calculate midpoint, mid value, first point plus last point by 2. So by using this formula, you can calculate the mid value. Now, one more important thing. Okay, first we will write one pseudo code for this. Now, what we are doing? If I want to perform the merge sort, I want an array of size some n integer, and I want the first element, what is the starting point and what is the ending point, last point. I'm considering index, first index, last index. Now what is the midpoint? Midpoint is equals to first plus last by 2. Otherwise, you can use one more formula also. First plus last minus first by 2. Both are same. 2 into first plus last minus first by 2 is nothing but first plus last by 2. You can use this formula or this formula. Generally, for overflow operations, they will use this is the formula. For if it is a large array, we can use this formula. Otherwise, if it is a small array, you can use first plus last by 2. Now, first what we have done, once we calculated the mid value, we called the merge sort again here. Again, we called merge sort. For what? For the first we divided, we got left and we got right. And again, we are dividing. So it is a divide and conquer is nothing but a recursive operation. Recursive operation we are going to perform. So continuously we will call this. We are going to divide right now. So how many times we have to divide? Left side we have to divide once, right side. So let us consider this is the left side and this is the right side. Okay, now left side we have to consider and right side. Now when we are writing a code, what we have written merge sort array of size n, and first and last we have to write now. Similarly, merge sort also array. And what is the first one? First index is first only. What is the last index in the left side? What is the last index in the left side? Is the midpoint. This is the midpoint. So first and last midpoint is the indexing of the left side. Mid plus 1 and last are the index for the right side, right? No. So now when I'm calling the left side simplification, or we can say left side merge sort operation, if I want to perform like a divide operation. So array first comma mid, first index comma mid index. And if I want to, anyway, this is for left side array, sub array you can write. Now merge sort right side, what we have to do, array as array and mid plus 1 comma last index. So this we will use for right side array. Okay, now once we are dividing, we got the a single element. We further we cannot divide it. That what we will call, this is the base. So this is the last point, or we can say the base. These are bases. So in this base, the first element and last element both are same, because only one element, So now what we are going to do here, if in the merge sort only, if first index is greater than or equal to last index of a, what does it mean? We reach to this position, individual, only one element is there, 9, 3, 6, 5, 2, 8, 7. We reach to this position because further we cannot perform the divide operation. So once you came to that position, first is greater than or equal to last, then you can return the element. You can return the element. Okay, no? Now we perform the merge sort by dividing operation. Now what we have to do? We have to perform the merging. How to merge that? We will create one function, and as of now, I will write here one merge operation I am going to perform. In this merge operation, we required array of size n, and your first element, your last element, and midpoint. These elements are, like, these parameters are required when I am writing a code. So now this is one function. So inside the function, I will call this merge. So now what is the purpose of this merge? Now when I write here merge of same parameters, array of size of n, comma, first element, first index, last index, and midpoint. Here I'm going to create one vector, which is a integer type. Now left side, whatever it is there, just consider left side whatever is there, we given the name it as I. Right side whatever the elements are there, we will make it as j, right? No. So now what I will do here, so one vector we created with integer, and I is the first. I is first one, first index, that is 0 generally. What is j is starting from? You can see here I, this is the left side is I, this is the first, and J, what is the first index? Mid plus 1. So same I'm going to write here, J is mid plus 1. Mid plus 1. Left side is starting element, starting index, that is first index. This is the left side. Left side sub array starting index. This is right side sub array starting index, right? No. What we are going to do here, while I less than or equal to midpoint, that means left side complete array. We are going to come first. We are going to compare this. J is less than or equal to last index, right now. So once if this condition true, what we are going to do? Array of I, we are going to compare with array of J, and we whatever whichever which one is minimum, that we are going to push to the vector. Either array of I is minimum or array of J. Which one is minimum? That we are going to push into the vector. Once we perform this, then the whatever the temporary vector we created, temporary vector we are used, we will copy to the original array. Okay, no? So this is the pseudocode if we want to write the program. Now, how to write the program? Now we will see. Now, first few lines is same. Now I will open the Visual Studio. Here, so hash include IO string. We want vector also. Hash include vector and using namespace. Now, here we are going to create the first one main function we will write int main return 0. So now here we are going to write the one array we are going to create int array of 7 elements we created. Now what are the elements we used in this program? 9, 3, 6, 5, 2, 8, 7. So these are the array elements we use. And what is the n value here? N is equals to 7. Now, what I'm going to do here, I want to create one function called merge sort. Okay, no. So now I will create one merge sort. I will call this function. So in this merge sort, what are the parameters I have to pass here from here? So this is int n. I will take it as integer n. Now anyway, this this function we didn't create it. So that is what it is showing red color. It's okay. So now what we have to do here? It is an array. You just just go through the pseudocode. What are the inputs we have to pass? So now when we want to create the merge sort, the first index is 0 and last index n minus 1. You can write it as 6 or n minus 1 you can write. Now I'm going to create the function over here. In this function, I will create one void merge sort. same parameters. I will take it as inputs over here. So now what are the parameters? Array. So int array, comma, so int first, comma, int last index. So now I'm mentioning the index. So in the divide and conquer, what is the first step we have to do? We have to calculate the midpoint. Int mid is equals to, I told two formulas, either you can use first place last by 2. You can use this, or you can use first plus last minus first by 2. Any one formula you can use. Now, what is the other formula? If I may comment this, first plus last minus first by 2. Any one we can use. Either both will give the same answer. Once we calculated the midpoint, what is the next step? Again, we have to call the merge sort. Again, we have to call the function. Since it is a recursive function, we will call the merge sort again over here. Now again, I will write here merge sort. So now I want for the left side and right side two. I have two times I have to call merge sort. I have to call two times. Is it right? No. So now when I'm calling first time, what is my inputs over here? This is one array, and I want the first index, comma, mid index, and in the right side, this is for right side. This you can say left sub array, left sub array divide operation. Now here array, comma, mid plus one, mid plus one, comma, last index till last. So this is for right sub array divide operation. So we can write it as right sub array divide. So this also divide. Now we have performed, we calculated the midpoint and we performed the left sub array and right sub array. So till what it will calculate, till what it will perform, till the base condition reach. What is the base condition? Only single element it should be. Then only it is going to terminate. Now, once we got the single element, what we have to do? We have to do the merge operation. Right now. So now first we have to find whether it is a single operation where we will get it. So now if first this condition, once you just refer from the pseudocode, first is greater than last. Both are same. If first equal to last, that means only single element is there. Then you can return the element. Once you got the single element, this merge sort will get over, and now we are going to perform merge operation. Merge operation. For the merge operation, that means first we have performed the divide. Now conquer merge operation we have to perform. How to perform the merge operation? Now again I will take the left side, right side, array size. So now array I will take, and first index, comma, mid index, comma, last index. In the same order, you can take it as. Now, what we will do, we'll create one more function with merge. So now what we are going to do here, one more function we are going to create here, void merge. In this, whatever the order we have taken, same we have to take in the same order. So int array type, int array, and int first, int mid, int last. So this is what we have taken now. Same thing we are going to consider over here. Now, here, when we want to merge this, we are going to create one temporary vector, which is a integer type, and it's a temporary vector I am going to create. Now, in this temporary vector, whatever the left side is there, that is int I is equals to, left side means starting index from the first. Int j is equals to right side. So right side where it will start? Mid plus 1. You can refer that. Mid plus 1 in the right side subarray. Left side subarray will start from the first, that is 0 index. Now we have to compare the elements, and whichever is new, that we are going to write. Now what I will do, while, so it's a continuous operation I have to perform. So in this while, what we have to do, till the last element reaches I less than or equal to mid and j less than or equal to last. If this condition satisfies, you can exit. Because till that, the loop should, that means what we have to do, what does it mean? Every element in the left subarray, we are comparing with every element in the right subarray. Till that, this loop will continue right now. So now here, if array of I is array of I less than or equal to array of j. Which one is lesser? I is lesser. So if I is lesser, what we have to do? We have to push that into vector. So now what is the vector we are using? Temp. So temp dot push underscore push back. Push back of array of I. Once we have done this, we have to do the I plus plus. Increment we have to do. Once we inserted that. Else temp dot pushback array of j. So instead of, oh, sorry, this is j. So instead of I plus plus separate, no need to write. Directly here you can write it is I plus plus. Both are same. Once this loop executes, you return I plus plus, or here if you write a j plus plus, both are same. If array of I less than or equal to array of j, right now. So now, otherwise, what you can do here, you can write I plus plus. Here you can write j plus plus. That means incrementing next value. So once we have done this, Now, now, now what we have to do, for example, in this case, if you observe, 356, I mean 2356 is inserted and 278 also inserted. What is the leftover one? 9. So what we have done, if nothing is there to compare, directly we have taken back here. No. So that we have to write in the code. What we have to write is I is mid. That is the last point of I, last index. Because in the left side, the last index is mid. In the right side, last index is last we have written. No. Right. So that we have to check the condition. For example, so we completed this while. Once if this while is one last element, it may we may left that we are going to write here while I less than or equal to mid. I less than or equal to mid. So that we are going to push to the temp. So temp dot push back array of, because our I is left over. So you can write increment here only. Instead of writing next step I plus plus, here only you can write that. Same way we will write one more this one. While j is less than last, it say last one element, it will be left over in the left subarray or right subarray. No, that we are going to write here. So now j is less than or equal to last. So temp dot push array of j. Now once we have done that, now divide I mean we have a big array, we are divided into small array, and further we are again we have merged to two subarrays, right now. Now what we have to do, that vector we are going to convert like a, we are going to copy the temporary vector to our original array. For that, what we will do here, for we will use for loop for int index. Index is equals to first, index equal to first, and x is equals to 0. This index till end index is less than or equal to last, less than or equal to last, and index plus plus. So now if first is greater than same, first is greater than we will write here. I want to copy to from the vector, right? So now what we will do here, in the array of index is equals to temp of x. temp of x. So when we have done this, we will copy the temporary vector elements to array. So what we have to do? One more increment. So all elements we are going to shift to the array. So once we have done this, we will use the one print. Here was semicolon. So now we will use one print function. Void merge sort, and here we can use one print function. So after sorting, we will use the cout function to display the sorted array. So void print array. So now if I want to print the array, what are the parameters I want? I want int array, comma, how many elements in the array? Int n. Now for all elements I want to print, right? So now for int I equal to 0, for all elements int I equal to 0 to I less than n, I less than n, and I plus plus. Till that, what we have to do? We have to print out, right? See out. We can write see out array of I. Can give in space, and here you can give see out inline. That's all. Now, if we run this code, okay, we didn't call the print function here, right? So now here we will call that print array of, what are the parameters? Array, comma, 7. Or we can say n, you can write how many, you can write here. Now you can see this line, I less than or equal to mid and I less than last given. So this is the mistake. Now we will run this code. So now we will get the output as 2, 3, 5, 6, 7, 8, 9. So this is how we can perform the merge sort. So remaining classes I will upload like this online. If you have any doubt, you can come and ask me. Thank you.